Hi guys, I hope all of you are doing well. So I welcome you all to yet another video in this AWS Data Engineering Certification course, and in this particular video we are going to see how we can launch MySQL database on an RDS instance using the full configuration mode. So till now, we have launched multiple other database engines like Oracle DB and MariaDB in the full configuration mode, as well as we have launched all the other database engines, that is Postgres, DB2, even MySQL in the easy configuration mode, or I would say the easy create mode in our previous videos. So if you are not very well aware about RDS and how exactly RDS works, what are the different components in RDS, so I would highly recommend you guys to first of all watch those videos and then you can continue watching this particular video. So with that said, let's get started with this video and let's get straight into the system. So as soon as you will be logging into your AWS console, this is the kind of dashboard that you will be seeing, right? Here you will have all the shortcuts and all the, I would say, a kind of summarized view of all the things that we are doing, right? So if you are following me in this particular course, for sure you will be having Aurora and RDS here in your recently visited card, or else what you can do if it is not available here by any chance. So what you can do, either you can click here on view all services, or even in this top search bar, you can directly search for RDS, right? And here the very first link that will be available, you can click on this particular link and you will be redirected to the dashboard of RDS, right? So earlier it was the dashboard of the AWS console. Now you are redirected to the dashboard of the RDS service. Okay, so this is a service specific dashboard that we guys can see. Okay, here you can clearly see Aurora and RDS, right? So we have the dashboard. So this is the dashboard of the Aurora and RDS. Then we have the databases. Then we have our query editor. We have our performance insights. We have our snapshots, exports in Amazon S3, automated backups, reserved instances, proxies, subnet groups, parameter groups, options groups, custom engine versions, zero ETL integration, event and event subscriptions. If we have any kind of recommendations and all those stuff, that thing also we can show, we can see right here in the dashboard itself. And all the required hyperlinks and parameters are given here also in the resources section. Okay. So first of all, the very first thing that we have to do is to create or launch a RDS instance with a MySQL engine, right? So I will click on this particular database instance. Okay. One more thing that I can do is I can change the region of my instance, right? So currently my active region is what? North Virginia, or the code of it is US East 1, right? Technically, I have talked about it at multiple places or multiple times. I would say that technically the resource that we are deploying should be either near to the highest cluster of users that we are having, or if we are doing it for a personal project, you can say, so if it should be nearest to us, but it's not mandatory, right? So I can even leave the region as North Virginia itself. It hardly matters, right? Any region that is available, we can launch it at any part of the world. So here what we will have to do is we will have to click on create database. Okay, so now here you will be able to see choose a database creation method. So again, there are two methods. There is the full configuration mode and then there is the easy mode, which we have been doing till now. Okay, so configuration engine options wise, I will click on MySQL because I have to choose MySQL, or I want the MySQL database engine to be initiated. Okay. Now here if I click in the easy create, so you will be able to see a very limited options that we have in order to create the instance, right? So we have our instance size. We have only three options that we can choose from. So it is the production level size, which is DB R7G XL, right, which will have 4 cores of CPU, 32 GB of RAM, 400 gigs of SSD, and the charge will be around 2 USD per hour. Okay. Then we have the dev/test kind of instance, which is of R7G dot large. which is having 2 cores of CPU, 16 GB of RAMs and 200 gigs of SSD, and you will be charged only 0.27 US dollars per hour. And we have the sandbox sorry, we have the sandbox instance, which is of T4G micro, 2 cores of CPU, 1 GB RAM and 20 gigs of SSD, right? And it will only charge 0.019 USD per hour. Okay, so we are only having 3 options with respect to the instance size, right? Then we have our database identifier, master username. We can do some kind of credential management. We can set up some kind of EC2 connection, and that's it. Okay, these are the few options, only few options, 3 to 4 options that we are having, right? That is choosing the instance size, choosing the database identifier name, choosing the master password, and choosing the master username and choosing the password of it. That's it. That's all we have as an option to be chosen in the easy create mode. Okay, here you can also read use recommended best practice configurations. Some configuration option can be changed after the database is created. Okay, but if we go ahead with the full configuration mode, here you will be able to see you set all the configuration options, including ones for availability, security, backups and maintenance, right? So here you will be able to see the engine options that are there. So obviously we have to go ahead with the MySQL database. Edition wise, you will be able to see MySQL Community Edition. Okay, engine version wise, so view the engine versions that support the following features. So here you will be able to see all the engine versions that are available, right? So the latest version is 8.4.7. If I scroll at the top, we also have our version 5.7.44 also. We have 8.0 version also, and then we have 8.4 version. Okay, so there are these 3 major versions that are there, right? And I hope you guys are aware about the fact that how we see the versions. So this, let me open my Epic Pen. Okay, so let's hold on for a second. Okay, it's going back. Okay, let me show you here itself, right? So here, this one, that extreme right one, okay, this version is usually called as patch. Okay, this is called as the patch. So if there is some kind of minor bug fixes, minor changes, right, some kind of you can say some minor issues are there, so we do the patching of those things, of those bugs, I would say, right? And we roll out a new patch version of it. Okay, so let's suppose there is some kind of a patching that has been done, so the newer version will be something like 8.4.8, right? Then you can have 8.4.9. okay, so there won't be any kind of feature change or any kind of major update that will be there between these two versions. Okay, they will be almost compatible to each other. Okay, so this is called the patching version. Okay, then we have, let me change the color of the pen. Okay, if I talk about this 4, okay, so this 4 is called as the minor upgrade version. Okay, so this is the minor upgrade version. So minor upgrade version means there is a minor, you can say, feature, right? Or maybe some kind of security issue was there, and the developers have fixed that particular security issue, right? Or a very basic functionality has been added, right? So there, this minor upgrade will be rolled out. So it can be, so suppose this is 8.4.7, so it can be something like 8.5.0. okay, so now from 8.4.7, right, till 8.5.0, so this is the minor upgrade, or you can say the minor version change has happened. Okay, then if I talk about this 8, okay, if I talk about this 8, okay, so this 8 is called the major version upgrade. Okay, so it is the major version upgrade. So major version upgrade will consist of what? It can consist of a major feature change that has been done. Okay, any absolutely new feature has been added to the database engine, right? Maybe some kind of performance optimization has been made to the database engine. That particular thing also comes under the major version upgrade. Maybe there was some kind of a very sensitive security issue that was there, and the developers have fixed that particular issue, so they will roll out a major version upgrade. Okay, so major version upgrade will look something like this. So let's suppose from 8.4.7, right? Now if you have to upgrade to, let's suppose 9.0, right? 0.0 or maybe 0.1 or any other version, right? So here you can see this is a major version upgrade that we will have to do. Okay, so this patch version upgrade and the minor version upgrade, it can be handled by RDS automatically or by AWS automatically. Where it will be handling these version upgrades automatically, I will let you know. Okay, but this major version upgrade we will have to do manually. And again, we have to keep in mind, it's not just that whenever MySQL rolls out from, let's suppose, version 8 to version 9, okay, we can blindly come and upgrade our version. No, that is not a good practice. What we should do is, first of all, we should launch a test environment, right, with the latest version. We should check if our existing code, existing infra is compatible with the latest version. If it is compatible, then only we should try to upgrade to the latest version. Else we should first of all make the required changes to our code base, to our infrastructure, and then we should try to upgrade our RDS instance to the latest version. Okay, so this is the correct practice and the correct path to upgrade to the latest version of the database, of any database engine, not only SQL, right? Regardless of any database engine I am talking about, this is the best practice that we should follow. Okay. So here you can clearly see that we are going ahead with the latest version upgrade, latest version that we are having for the engine version. Okay. Then here you can see enable RDS extended support. So if you want to read, so Amazon RDS extended support is a paid offering. By selecting this option, you consent to being charged for this offering if you are running your database's major version past the RDS end of the support date of the version. Okay, cool. So this is usually for, let's suppose if there is some kind of version, right, that I am using, but the support to that particular version has been drawn back from the community. Means community no longer give you support for those versions, right? So if you want support for those versions which is not supported by the community now, so you can click and you can enable this RDS extended support, right, in order to get support from the AWS people, right? There will not be the MySQL developer community that will be giving the support. It will be the AWS people who will be giving you the support for it. Okay, but currently because we are using the latest version itself, so we don't require this extended support to be enabled. Okay, again, you will be charged to get this particular extended support enabled, right? So unwantedly, or I would say without use, right, I would say that if you don't require it, don't try to enable it, right? And this is the minor things where we can save our money, right? Ultimately, if we are a very, very large organization, right, and one single click can cost us a lot of dollars, right? It can cost us a lot of money, right? Because if I have checked, I will be charged, right? Even though I am using the latest version of MySQL and there is a community support that is available to me, and if I check this particular box, right, knowingly, unknowingly, right, I will be charged for it. Okay, so you should be aware about these minor things also when you are working in an organization, right? Now we have different templates that we can choose from. So choose a sample template to meet your use case. So first of all, we will have the production template. So uses defaults for high availability and fast, consistent performance. Okay, then we have the dev/test environment. So this instance is intended for development use outside of the production environment. So the name itself suggests that if we want to do some kind of development, some kind of testing, so in that particular case, we can use this environment. And sandbox, so to develop new applications, test existing applications, or gain hands-on experience with Amazon RDS. Okay, so if you are maybe using it for the first time, right? If you are developing a very small application, or maybe you are in the initial development phase, then you can go ahead with this sandbox template, right? So let's go ahead with the production template in this particular video, so that we have the access, I would say we have the option to configure all the things. Okay, now here you will be able to see availability and durability, right? So deployment options, so choose the deployment option that provides the availability and durability needed for your use case. AWS is committed to a certain level of uptime depending on the development option you choose. Learn more from this particular link. So there is this SLA, that is service level agreement between us I would say, or maybe whoever the user is or whoever the payee is, between the payee and Amazon. Okay, so here you will be able to see, okay, all the SLAs. So here, if the monthly uptime percentage is less than 99.95%, so here you will be able to see there is a claim, right, that they provide 99.9% uptime. Okay, here for this particular deployment also they will provide you 99.95% uptime, and here for the single availability zone deployment they will provide 99.5% uptime. Okay, so if the uptime is less than 99.95% but equals to or greater than 99%, the service credit percentage will be 10%, means you will be kind of discounted 10%. Okay, if it is less than 99% but greater than equal to 95%, you will be discounted 25%, and if the uptime is less than 95%, you will not be charged anything. Okay, so this is for the multi-availability zone deployment. And if you are going ahead with the single zone deployment, right? So here from 99.5% till 99%, 10%, then 99 to 95, 25%, and less than 95 is 100%. Okay, so this is a kind of SLA. Okay, if you want to read it more, you can read it. Okay, so this is a kind of agreement that is there between the customer and the AWS. Okay, so here again we have in the multi-availability zone cluster deployment, we have two options. So we have a 3 instance option and we have 2 instance option. So here again, if you can read, so creates a primary database instance with 2 readable standbys in a separate availability zones. This provides 99.5% of uptime, redundancy across availability zones, right? Increased read capacity and reduced write latency. Okay, so here you will be having your primary database. Okay, so this is your primary instance, right? Means whenever a user will try to interact, right, or he will try to write anything, right, he will try to insert anything, the data will get inserted into this particular instance, right? And here also you can clearly see with the icons that this is a write plus read instance. Okay, you can clearly see with the icons also, right? And here also you can see write plus read endpoint we are having. Okay, then according to the definition itself, you will be able to see, right, that we will have 2 readable standbys in separate availability zone. So here you can clearly see this primary instance is deployed in the availability zone 1. Okay, then we have different reader endpoints that we'll have. So this reader endpoints will be deployed in different availability zones. They will be in the same region, but inside we are already aware about the fact that in one region, right, we have 3 availability zones, right? At least 3 availability zone, right? So we will have AZ1, right? We will have AZ2, and we will have our AZ3. Okay, at least for all the reasons that are there for AWS, right? They at least have 3 availability zones. There can be more than 3 availability zone also, for one single region. Okay. So here the reader instances will be deployed in separate availability zones, and these availability zones are isolated from each other. Means uh, if something happens to one availability zone, the other availability zone will remain functional. Means each and everything, right from, you can say, uh, electricity connectivity till the cooling part of it, till the power part of it, is from different vendor, right? let let's say this is my availability zone 1. Okay, this is my availability zone 1, this is my availability zone 2. Okay, and this is my availability zone 3. Okay, so it's not that we just have machines in this availability zones and these machines are communicating, right? We require power, right? We require power. Power means electricity, form of power, right? Maybe any other power, some renewable kind of energy we are using and whatnot, right? So we will require some power to get these machines running that are there in the availability zone or in the data center, I would say, right? Then we will have some kind of cooling facility that should be available, right? Then we should have some kind of internet activity that we should have, right? Then we may have some kind of backup, right? Power backup that we are having and whatnot, right? So there are n number of things that should be there inside one data center. Okay. So if in availability zone, maybe let's say vendor A is providing us the power, vendor B is providing us the cooling, right? Vendor C is providing us the internet, and vendor D is providing the backup of the power. Okay. Now these vendors will not provide me these facilities in the availability zone 2. We will have separate vendors for it. So let's suppose we can have vendor E for it, right? We can have vendor F for the cooling part of it, right? Maybe G for the internet part, and maybe H for the backup part. So that even if for any reason this vendor goes down and my electricity in my data center goes down, right? My availability zone 2 is not affected because this vendor A is not able to provide me electricity, because I'm in availability zone 2, I'm getting the electricity from vendor E, right? Similarly, here you will be able to get any other vendor, let's say OPQ, RST, something like that. Okay. So here there will be different vendors that will be providing you all these, or not us, basically Amazon, right? They will be providing Amazon all these facilities, right? And these vendors will be different for availability zone 3. Okay. So these availability zones are totally isolated from each other, so that if one availability goes down, the other availability zones are up and running. Yeah, if there is any kind of natural disaster, right? Let's suppose if there is an earthquake in a massive region, in that particular case, there is a possibility that these availability zones can also go down, right? Then comes the idea of the region wise replication, right? So we have one instance here in one region, and then we can deploy our backup instance in some separate region. Maybe I can deploy it in USA region, and this I can deploy in the Europe region, something like that. Okay. So this is about this. Okay. So we were talking about, okay. So let me get my pen. So we were talking about this reader endpoints, right? So here you are able to see with the icon also that these are only the read endpoints. Means if the user only wants to read the data from the platform, then they will be they can access these endpoints also. Okay. So here you can see, right? So if I am the user, okay, if I want to write the data, so the data will be written in the primary instance itself. So this is the write operation. Okay. If I want to write the data, it will be written in the primary instance. Now this primary instance will be creating a replica to these readable standby instances, right, in a real time, or you can say in a near real time, not exactly a real time. I will say as a near real time thing, right? So that now if this user wants to read the data, right? So he can also read the data from this particular instance, right? So let me change the direction of the read. Okay. So if he wants to read the data, so he can read it either from this instance also, right? If he wants to read it, or he can also read it from this instance. Okay. Or he can also read from this instance also. Okay. It's not mandatory that the read will be only from these standby instances. Even the primary instance allows us to read the data from the instance. Okay. So how this will be, so here you can very clearly understand now that why the redundancy across the availability zone is important, how it will increase the uptime, and how it will increase the read capacity, because we are having three options from where the user can do the read operation. Now how it will reduce the write latency. Write latency means, let's suppose I am a user and I want to write some data to the database, right? So how much time is it taking to write the data into the database? And that is what latency is. Let's suppose I am getting 10 microseconds for the data to be written into the database. So 10 microseconds will be the write latency. Okay. So how write latency will be reduced in this particular case? It will be reduced in such a way. So SQL databases, they follow something called as ACID properties. Okay. ACID properties. And in ACID properties, there is this property called as atomicity. Means till one operation is not done, the other operation will not start. So if there is a multiple read request on this primary database itself. So first of all, before the write database. Okay, so let's suppose we are having a read request, we are having a read request, we are having a read request, then we are having a write request, then we are having a read request, something like this. Okay. So till these three read requests are not delivered, right? Or I would say are not processed, till then this write request will not be processed. So I can have a high write latency in this particular case if I'm using a single database instance, right? But if I divide these three read requests into three instances, right? So I can serve one read request from this instance, one read request from this instance, and one from this instance. So these two instances can parallelly allow the users to read, whereas this instance has given one or processed one read request and now it's free. So it can allow the user to write the data into the database. Okay. So here it has also reduced the write latency because it only has to serve one read request, right? And then the deadlock will be over, or I can say the server will be free. So it will allow the user to write the data into the primary database instance. Okay. Hence, the write latency will be reduced. Okay. So I hope you have understood this point, that how read capacity will increase and how the write latency will be decreased, or it will be reduced. Cool. Then if you have the two instance deployment, so here you will not be able to see these 2 points, that is increased read capacity and the reduced write latency, because here it will only create a copy of it. Okay, so just let's read it. Creates a primary database instance with a non-readable standby instance in a separate availability zones. This setup provides a high uptime and redundancy across availability zones. Means here the user will only have one single instance to interact with. Okay, it will have only one single instance to interact with. This instance, okay, will serve both the write and the read traffic. Okay. This primary instance will have a standby instance. Means if this instance goes down, so this is in availability zone 1 and this is in availability zone 2. Okay. So if this instance goes down, right, the system will automatically switch over to the standby instance. So the user will start getting traffic from this particular thing. That's it. Till the time my this primary instance is up, user will not be able to interact with the standby instance. So this instance is not interactable or not usable by the user. Okay, so only technically if I talk about, so I only have one single instance to be used or to be that can serve the users, right? We have a standby or a clone instance which will only come into picture if my primary instance goes down. Okay, so that's the reason this two instance deployment is not having an increased read capacity and a reduced write latency, because we are all in all at the back end we are only having one single instance that serves the traffic. And here if I talk about the single deployment, so here we don't even have the standby instance. So creates a single database instance without the standby instance. This setup provides 99.5% of uptime and no data redundancy. So there is one single instance, and using one single instance the data the user will be able to interact. Okay, so let's go ahead with the 3 instance deployment. Okay, then we have our settings part. So here I can provide some kind of database name. So I can provide as, let's suppose, MySQL DB. So MySQL hyphen database. Okay, then I can give any master username. So let admin be by default username. I can keep any username, right? Let's suppose my name or whatever name you want to keep, admin name, right? You want to, your organization name, right? Whatever you want to keep, you can keep it. Then talking about the credentials management part, right? So we can have two options. So either we can go ahead with the managed AWS secrets manager service, right? Or we can also go ahead with the self-managed part. Here RDS generates a password for you and manages it throughout its lifecycle using the AWS secrets manager. And here we have to create our own password or have RDS create a password that you manage. Okay. So till now we have been going ahead with the managed self-managed password. Let's go ahead with the managed AWS secret password. Okay. So here you will be able to select a kind of encryption key. If I want to add some other encryption key, I can add it also. But let's go ahead with the by default thing. Database authentication option. So password authentication, password and IAM database authentication, whatever is required. So I will go ahead with the password authentication only. Okay. Then we have the instance configuration. So the database instance configuration option below are limited to those supported by the engine that we have selected above. So we have 3 classes for the instance configuration that we can choose from. So we have the standard class, we have the memory optimized class, and we have the compute optimized class. Okay. So if you remember in the easy create version, we only had 3 options, something like production, dev test, and sandbox, right? To choose the size of the instances. Here, even if I go ahead in any of the class, we will have n number of options to choose from. Okay. And you can see we are having the instance size as large as 32 XL. Okay. So I guess this is the largest one here. Okay. So yeah, 32 XL is the largest one. Okay. No, we also have 48 XL. Okay. We also have 48 XL. Okay. So 48 XL is the largest one. So here you can see we will have 192 cores of CPU, 768 gigs of RAM, right? Elastic block storage bandwidth will be 40,000 Mbps, right? There will be an instance storage of 11.1 TB and a network bandwidth of 50 Gbps. Okay. And this instance size is for the standard class, that is M class. If you will look closely here, so even the instance name is what? db.m8g D48XL, right? So it means it belongs to the M series or it belongs to the M class, and 8G is the generation of this particular instance. This is this M6I, it means this is of the 6th generation. You have M5, it means it is of the 5th generation, right? M series, and this is the instance size. XL is the instance size, or extra large is the instance size. Okay. Then if you go ahead for the memory optimized classes, right? So we will be able to see the R series, right? Here also you can see, we will be able to see the R series, right? So we have R5, okay. Then we have R6, okay. Then we have R8, Then we also have the X series. Okay. Here you will be able to see, right, 32XL, okay, which is having 120 core, 128 cores of CPU, 4096 GBs of RAM, okay, 80,000 megabytes of megabyte per second of elastic block storage bandwidth, instance storage of 3.7 TB, and network bandwidth of 100 Gbps. Okay, so I hope this 32XL is the largest one. So is there any larger instance than 32? Okay, so the bottom one was larger. Okay, so I guess this 32 is the largest, right? 4000 GBs of RAM, you can think about it. Okay, so we have 48XL also. Okay, but here the RAM is less, but the cores are more, right? Here we have 190. This is R8 generation. Here we are having 192 virtual cores of 192 virtual cores. Here we have having 128 virtual cores. Here we are having 4000 GB of RAM, 4096 GB of RAM. Here we are having only 1536 GB of RAM. Okay. So again, if you require a high processing, right, in that particular case, you can go ahead with this 32XL also. Then we have the compute optimized classes, right? So these classes will have a smaller instance, I would say, but even the smaller instance are pretty large. Okay, here you can see 68 virtual cores, 128 GB of RAM, right? 19,000 Mbps of EBS bandwidth. Okay, 3.7 TB of NVMe SSD and 25 gigabyte per second of the network bandwidth we are having. Okay. So we can choose any of the instance, right? So let's suppose if I go with the memory optimized class and let's choose the smaller instance itself. Why waste money, right? Then talking about the storage type. So we are very well aware about the fact okay. So if I come to the storage part of it or the storage type part of it, so I can say, right, we are aware about the fact that we have majorly three type of storages, out of which two are used, I can say, for the production, right? So first we have the general purpose storage, and second we have the provisioned IOPS storage. Third is the magnetic storage, which is not even recommended by AWS. Okay. So if you will click here, so you can see we have the general purpose SSD or GP3. So performance scales independently from the storage. Okay. Then we have the provisioned IOPS SSD or IO1. So flexibility in provisioning IO. And then we have the provisioned IOPS SSD, IOPS 2. So low latency, high durability, and input output extensive storage. Okay. So let's go ahead with the IOPS storage. Okay. So here we can allocate how much storage. We can allocate from 100 gigabytes, or you can say 100 GB till 65,536 GB, right? So if let's suppose if you want 40 TB of storage, so you can just add two more zeros and the instance with 40 TB storage will be launched, right? So let's keep it 400 itself. Okay. Here talking about the provisioned IOPS. So IOPS means that how many number of input output operations per second you can do. Okay. So 3000 IOPS means that you will be able to do 3000 input output operations per second. Okay, it will not exceed this particular limit. If you are below this limit, it's totally fine, right? But you cannot exceed if I'm going ahead with this provisioning itself, that is 3000 IOPS per second. Okay. So IOPS basically means read and write operations. So we can perform 3000 read and write operations in 1 single second if I am provisioning this IOPS. Okay. So I will be able to perform 3000 read and write operations in 1 single second, right? If I want to increase it, if I feel like that, okay, my traffic is more, I can increase the IOPS limit between 1000 to 2,56,000 IOPS. But here if I'm doing 2,56,000 IOPS, okay, right? Currently I'm not getting the error. Let's suppose if I'm keeping here as 100. So here you will be able to see we are getting some kind of issue. So the maximum IOPS storage ratio is 1000. Means this ratio between allocated storage and IOPS should be 1000. Okay. So here if I am doing, let's suppose if I divide 100 by this, so the ratio that we are getting is, right? Let me guys show you the calculation. Okay. So if I do 256, okay, 0, 0, 0, okay, ratio 1000. Okay. So this ratio should be between 1000 is to 1. Okay. So if I divide, sorry, this is not 1000, this is 100. Okay, this is 100. Now if I try to find a ratio between these two, so the ratio is 25 is to 1. Okay, 2560 is to 1 is the ratio, right? I can cut these two 0 with these two 0, right? Simple as it, right? So this ratio should be within this limit, that is 1000 is to 1. Okay. So even though if I put 200 here, my ratio will not be there. Okay, if 200 if I put, so yeah, okay, it comes under this particular ratio. Okay, so here I will have to even keep in mind the ratio of it, or else I can provide any value here. Okay, again if I will provide obviously any value, so it will say that the maximum gigabyte storage allowed is only this much. Okay. So let's keep it as 200 itself. Okay. And okay, 200 is also not getting right now. So 200, yeah, even if I do 200, right, it will be less than 1000, right? So 2056, yeah, it will be 3 and 2 and 1, right? So 132 will, 1320 will be something kind of ratio is to 1 will be there. Let's keep it 400 itself. Okay. And now you can see we are having a good IOPS, but let's not keep this much IOPS. Let's keep it till 3000 itself. I guess it's more than enough. Okay. Now, if you want to add any additional storage configuration, enable auto scaling in multiple availability zone deployment, you can also do it. Currently, it's not, I would say, available for the multi-zone deployment. Okay. Cool. So now comes the connectivity part. So if we want to connect to any kind of compute resource, so this compute resource can be an EC2 instance or maybe a Lambda function also. So Lambda function is a serverless compute, I would say, right? So currently we are not connecting it to any kind of compute resource, maybe an EC2 instance. If I want to connect it to any kind of EC2 instance, I can just click on this particular option, that is connect to an EC2 compute, and then using this particular drop down, I can select if there is any kind of EC2. Currently, because there is no EC2 instance, so you can see to connect your database to EC2 compute resource, first create an EC2 instance. So I can just click on this create. So I will be redirected to the EC2 instance dashboard. There I can easily create an EC2 instance, and then it will be visible here for me to connect it to the instance. So currently I will let it be, and I will not connect it to any kind of instance. Do I want to make it publicly accessible? So yes, I can make it publicly accessible. So publicly accessible means the RDS assigns a public IP address to the cluster. Amazon EC2 instances and other resources outside the VPC can connect to your cluster. Resources inside the VPC can also connect to the cluster. Choose one or more VPC security groups that specify which resources can connect to the cluster. Okay. If I'm doing publicly accessible as no, so RDS does not assign a public IP address to the cluster. Only Amazon EC2 instance or other resources inside the VPC can connect to the cluster. Choose one or more security groups to specify which cluster can connect, which resources can connect to the cluster. Okay, so I will make it publicly accessible as yes. I can choose the existing VPC, create an RDS proxy. So yes, I will be checking it to create the RDS proxy. Okay. Then additional configuration wise, we have this default port that is 3306 of MySQL on which the MySQL runs, right? If I want this particular port to be any other port, in that particular case, I can specify that specific port also. Talking about the monitoring part, so we have two types of database monitoring options that are available. So we have the advanced monitoring where it will retain the 15 months of performance history. The fleet level monitoring will be there, and integration with the CloudWatch application signals will be there. If I want to go ahead with the standard monitoring, so again it retains the performance history of 7 years and pay with an option to pay for the retention of up to 24 months of the performance history. So here I can go ahead with the advanced monitoring part. Here I can even export all the logs that are available. Okay, enhanced monitoring for all the instances of the cluster. Okay, so let it be. So RDS monitoring role will be there. Granularity will be 60 seconds. Okay, if I talk about the advanced configuration options, if I check, so here you will be able to select the parameter group, right? I can enable the automated backups. Okay, how many if I want any kind of backup to be done, right? So what is the backup period that I want to keep? If I want to do any kind of specific window, if I want to choose, let's suppose if I want to make 2 AM UTC as my automated backup time, right? Or a backup window, I would say. In that particular case, I can choose a window of it. Okay. Then again, maintenance part, right? Here you will be able to do the same thing if you want to choose your maintenance window. So let's suppose it starts on Monday. Or I can say, let's suppose as Sunday. Okay, Sunday night at, or maybe Saturday night, so that even Sundays are lesser traffic. So let's suppose from 2. So here you can see maintenance window and the backup window of the database instance cannot overlap. So I can keep it from 2:30 maybe. Okay, so 2:30 I have set up the maintenance window. Okay, so here you can see with the current configuration, right, this will be my total cost that I will be incurring, and this is the monthly cost, right? Total monthly cost. So it will around $1,636 US, and provisioned IOPS is the highest cost, right? Because I have put up the highest limit of provisioned IOPS. Okay, currently it is not the highest limit. I thought that I have put here as 2,56,000. Let's suppose if I put here as 2,56,000. Okay, so you will be able to see that the cost will be increased. You can see here, right? If I want 2,56,000 IOPS to be done, right? Provisioning IOPS. So you can see 76,800 US I will have to pay, right? Again, if I am changing the instance size or something, right? Let's suppose I am getting the topmost instance. Okay, I believe this was the topmost instance, right? And let me make it to, let's say, 40 TB. Okay, so this is now, I would say, a kind of a super computer that we have, right? We are having 128 cores of CPU, 4000 GBs of RAM, right? 4096 GBs of RAM to be precise, 80,000 Mbps of EBS bandwidth, 3.7 TB of NVMe storage, right? And 100 GB of network bandwidth, then 40 TB of storage, allocated storage we have provided. Then we have 2,56,000 IOPS, provisioned IOPS that it can be done, means 2,56,000 input output operations can be done on the instance in a one single second. Okay, so now just see at the cost. Okay. So here our costing will be something like this. So the instance cost alone will be 1 lakh 33,292 US dollars. Storage will cost us comparatively, I am saying very less, that is 15,000 US dollars, and the provisioned IOPS will be costing us 70. Sorry, it is 6,800. Yeah, 76,800 US dollars. So overall cost will be 2 lakh 25,092 US dollars. So if I just convert it into INR, so it will be around 2 CR on a monthly basis. Okay, so you can see here, right? 2 crore 6 lakhs 96,616. So this is the monthly cost of this size of instance if we want, right? But obviously, why to launch this kind of unnecessary thing, right? So I will go ahead with the smallest instance, that is DB5 large, right? I can keep it as a bare minimum of, let's suppose, 200 thing, right? And here I can give the IOPS as 1000. Okay, and now just look at it. Okay, my bill has been now down to 961 USD, that is around, I would say, uh, 88,000 rupees. Okay, so again, I'm not saying that 88,000 rupees is a small amount, right? But comparatively, just you will be able to feel the scale that you can easily manage just a click of button, right? We just did a few clicks, we just changed a few parameters, I would say, right? I just changed the instance type, I just changed this value, and I just changed this value, and just look at the difference in the billing amount from 2 crore 6 lakhs on a monthly basis, we are down to 88,400, right? So this is what I wanted to show you, the scale and the flexibility that we are having on the cloud. Okay. So this is the kind of flexibility that we have on the cloud thing. Okay. So here we are now launching the bare minimum instance, I would say. And here to launch the instance now. So we have configured everything, each and every minor details, each and every minor configuration that we can do with our own requirement that we are having. Okay, so we have done all the configuration ourselves. Then I can just click on this create database button, and once I will click on this particular create database button, it will start launching my instance. So now you can see the cluster has been started to launch. So here you can see creating this RDS database proxy for the database. This your proxy might take up to 20 minutes to create and get available. Secrets manager and IAM policy access roles is being created. Okay, and creating the database SQL as well. Okay, so it will take some time to create this particular cluster. So what you can do is uh, you can jump onto the time frame where I have started talking again. So let's wait till this instance get created. Okay, so the database has been successfully created, and now this RDS proxy is still into the creation part. So let it get created, and then we'll be moving forward. Okay. So the database instances, the individual instances are now in the available state, right? And the cluster is still into the modifying part of it. It will take a few minutes. So guys, I will be right back. Okay, so you can start, or I would say you can skip to the time frame where I started discussing about the cluster again. Okay, cool. So now you guys can see that the database instance, as well as like all the instances, as well as the cluster, right, all are in the status available. So now we can look at the details that we want. So firstly, I will use the settings to get the database credentials. So here you can see, here we have the hyperlink of the AWS secrets manager. So I will click on this particular manage credentials. Okay, and it will redirect me to this particular credential, right? So here you will be able to see the secret name, right, the secret ARN, okay, and all these details will be available here. If I want some kind of sample code, so here I will be able to, let's suppose I'm using Python 3 to connect to my cluster. So here this will be the secret name that I will have to pass, right? Here you can see, okay, and I guess even ARN will be required here. Okay, ARN is not required, only the secret name is required. Okay, so here you can see this is how, and this is the most secure, as I would say, claimed by AWS, right? This is the most secure way you can manage your secrets and your credentials. Okay, so we can get our secrets and credentials here. This is the endpoint of my cluster. So here you will be able to see db.cluster dot. There are a few, I can say, some unique code, I can say, right, or unique characters that has been provided to the cluster so that it can be uniquely identified. And then there is this region.rds.amazon.com, right? And then we have our master name that is called as admin. So we have all the details right here with us. Cool. Now, if I want to get details of my cluster as well as if I want to get the details of my instance, both are easily possible. So if I will click on this particular tab, right, so I will get the details of my cluster in this particular case. Okay, so if I want to use code snippets, so do I want to use MySQL shells on Windows or maybe anything to connect to it? If I want to use Python to connect to the RDS instance, if I want to use Node.js to connect to the RDS instance, everything will be possible here. Now, what kind of endpoint do I want to connect? Do I want it to connect to the cluster endpoint? Do I want to connect it to RDS proxy endpoint, or do I want to connect to the data API? All will be like connecting to every kind of endpoint is possible here. If I want to use Cloud Shell, so this is how you can, here I can also use Cloud Shell. And if I want to use direct endpoints, I can also use direct endpoints to connect to my RDS instance. Okay, so these things are all about the connectivity with the RDS instance. Here you can see, if I want to set up some kind of connection with my EC2 or even with my Lambda, I will be very easily able to do using these links. So I can just click on this particular setup EC2 connection. If I have any kind of EC2 instance running, I will be directly able to select the EC2 instance right here, and I can just click on continue, and I will get an option to attach, and I can quickly attach the EC2 instance to my RDS instance. Again, if I want to connect it to some kind of Lambda function, so I can just click on this Lambda function, choose existing Lambda function. So currently I don't have any kind of Lambda functions created. If it would had been created, I can directly connect it to the Lambda function using this particular drop down, or I can directly create a new Lambda function here also. So I can name this Lambda function, right? Connect to the RDS proxy. So it will be the same RDS proxy in which my RDS instance is running, right? So it will be connected to the RDS proxy itself. You will be able to see the connection summary and all those things, right? This is my RDS instance. My RDS instance is connected to the proxy, and this proxy will be connected to my Lambda function. Okay. And all the details will be available here. I can just click on setup and the setup will be done. As easy as this. Then talking about the monitoring part. So you will be able to see all the monitoring matrices here for your SQL instance, or I would say the RDS instance. Okay, so there are total 144 matrices that are being captured here. Okay, so you can see aborted clients, aborted connections, active transaction count, analysis command, log bin uses, connection attempts, okay, uh, CPU utilization, created temp disk tables, all the details, okay. And if you look closely, right, so you will be able to see of every instance wise details also you will be able to capture here, right. So this mysql -db is the whole cluster that we are talking about. This is my first instance, this is my second instance, okay, and this is the third instance. So if you hover over the instance, that instance, I would say the graph about that particular instance will be highlighted, right. So you can see if I am talking about so I believe this is my primary database. If I just come here, so yeah, DB instance one is my writer instance. So writer instance means this is the primary database instance, and these two are the reader database instance that are available, instance 2 and instance 3. And here you will be able to look that these all are deployed in the different availability zone. So instance 1 is in US East 1B, instance 2 is in US East 1A, and instance 3 is in US East 1D. Okay. So similarly, if I come back here and so it will take just a few seconds to load it. Cool. So you can see all the details that you require to analyze your cluster, your individual database instance at any given point of time. All the details will be here, right? Even the database load CPU. So cluster wise, if you want to get any kind of details, you will be able to get here. Here you will get all the individual details. Okay, if I hover over it, okay, so you can see, right. So this is for the first instance, which is my primary instance, right. This is my reader instance, and again this is my reader instance. Okay, then if I keep scrolling down, you will be able to see different matrices that are being captured. Okay, file disk size utilization, file system files count, file space available, and all these details, right. You can just keep on scrolling and you'll be keep on finding the matrices that are available here. Cool. Then we have the logs and events details that are available. Okay, so all the details that are available about the logs and events will be available here. Configuration wise, you can see all the configuration details of the cluster. Okay, if you want to get the configuration details of the individual instance, so you can also do it like this. You can click on this instance, and now the configuration details of that instance, that is this db1 instance, is now available, right. You can see here mysql-db-instance1. If I select my cluster, so here you will be able to see the cluster ID details, zero ETL integration, maintenance and backup details, everything, right. Data migration, tags, recommendations, all the details will be provided right here in front of you. Cool. Now, the most important thing that I would like to tell you guys is, once you have done and once you have understood how you can do this particular deployment, the most important part is to delete the instance or delete the cluster, right. So here if you select the cluster and if you go to this actions button, currently this delete button is disabled, right. So what you will have to do is, you will have to go into this modify tab, you will have to scroll all the way down to this enable delete protection, and you have to uncheck it. Okay, you have to uncheck this enable delete protection, click on continue, click on modify cluster. Okay, so you can see the database cluster MySQL DB was modified, and now if you select the cluster and come here again, the delete button is now enabled. So I can click on this delete button. I don't want to create any final snapshot. I can acknowledge it and just type here as delete me, and delete DB cluster button is now accessible, and now in a few seconds my whole database cluster will get deleted. So now you can see the status has now been changed to deleting. So again, it will hardly take 1 or 2 minutes. So you can wait for it to get it deleted so that you can rest assured that you are not getting charged for any unnecessary things. So the few instances are down. It will be soon that the whole cluster will be deleted. taking a bit long time to get it deleted. Yeah, so now we can see that the cluster and the database, or I would say all the instances, has now been deleted, and now we can rest assured that we will not be charged even a single penny till like from now onwards. Cool. So this is how we will be able to launch, right, MySQL cluster, right, with I would say 3 instances in a full production mode along with all the details that we want. We can configure our database engines, we can configure our I would say instance size, we can configure what kind of storage do we want, what storage type I want, and how much storage do I want, what will be the provisioned IOPS numbers if I'm going ahead with the provisioned IOPS thing, right? Maybe then I can choose also my maintenance window, right? My upgrade window, my backup window, and I can also choose what kind of analytics do I want, and much more things are available in the full configuration mode of the RDS. So this was pretty much it, guys, for this particular video. I hope you guys learned something new in this video. I will see you in the next one. Till then, keep learning and keep growing. Bye-bye.